I'm CK. I bought a number of small kits from eBay and Amazon over the past couple of weeks, and we'll be putting them together. This is a little electronic dice kit. It costs $3. It's from a maker I have built from before, EQ Kit out of China. I like the previous kits of theirs I've made, so we'll see how this one goes. Hope you enjoy it. So let's see what we have. As I said, this was $3 from eBay, so it's obviously very basic, but we want to take a look at it and see how interesting it is for a new builder or a learner. So let's take a look at the circuit board first. As I said, it's from EQ Kit, which is good. The front looks fine. All the part components are clearly marked as to what they are, and that's always a big positive. On the back side, the board looks good. The traces are real nice. Again, it's single traces, no traces on this side, only traces on this side, which I like for beginner builders because they can then follow along. They can follow like this ground plane line. They can follow where the transistors are getting their input and providing their output from, and all that. So this is a nice little board. It's not perfect. The plating is not through hole on the pads, but that's okay. That's for a kit like this. I don't really expect that level of circuit board. Now we'll dump out the parts and see what we have. Looks pretty straightforward. Obviously, there's no written documentation in the package, but that's okay if there's some good documentation online. And in fact, with the board layout, you don't really need documentation. Capacitors, bunch of resistors, couple of 4 or 5 transistors, a electrolytic cap, a disc cap, and 2 ICs. This one's Texas Instrument 1, we'll look it up in a little bit, and this one also is a TI chip. So good chips, and the logos look sharp. In other words, it doesn't look like a counterfeit, it looks real. We'll see this one. This one may be a little suspect, but that's okay too. As we look at online at the listing, because that's where much of the information you can get about these kits is. It's in the listing instead of in packaging online. Good. Supply voltage 4.5 to 5 volts. That's good because that's not marked. Many soldering pads do not come off easily. Well, that's good. 2 becomes less likely to occur from the bending. Refer to the non-human case resulting bending. Poor sheet with time and changes in the environment arise from bending. Not quite sure what that means. Impedance more stable and reliable. Okay. I'm not really sure. They may want to get a better translation program, or just get someone to do a rough proofread. Even if they don't know English extensively, you could probably dress that up a little bit. So here's the instructions. You play by hitting the switch, and okay, here's PayPal, delivery time, and that's it. So really, I guess the only thing that we didn't know from the board was the power coming in. Now we do. It's 4.5 to 5 volts. So the rest of it, because all the information is clearly marked on the board, we should be able to lump this together pretty quickly. In fact, from the look of this board, oh wait, before I go off into fast mode to just do the soldering, let's take a look at what these chips are. So this is a TI, actually I can probably look on this listing. No, it doesn't have a parts list. Oh well. So this is an NE555, so that's a 555 timer oscillator, so that's good. And then this, the CD4017, probably is an LED driver, but let me look it up. So yeah, this, the 555, that's a 555 timer that they'll make. So after you press the switch, Q1 is on, and pin 3 of the 555 outputs a pulse. 5 output ends of the 4017 output the high level by turns. So what is the 4017? I think CD4017. That's a decade counter. Okay, so that's a decade counter chip. So it's going to, the 555 timer is going to output a bunch of stuff. The decade counter is going to count it and light up the appropriate LED, or signal the transistors to light up the appropriate LED. So, oops. So that will be interesting. And we'll see how it's wired together to see how that actually makes a variable dice roll. Probably, if I'm thinking about it, it's going to depend. There's some randomness in how long somebody's holding the switch down. But we'll take a look at it when we get done. And as I said, since this is a relatively straightforward kit, there's not much interesting in the soldering here. I'm going to go into fast motion with no live commentary as I put this on. So enjoy watching fast motion soldering and some background music. So that's it. Pretty quick and simple build, as you saw. A couple of things. You might have noticed I did bridge as I was soldering fast. I did fill a hole in and had to unsolder the hole. So you always have a solder sucker handy to be able to do that. The other thing, when I put the power connector in, it wasn't really clear on the board which way was which. So I set it in, I actually soldered it and then said, oh, put the other half in, and I had the polarity reversed. So I just heated up the pins, pulled it back out, and resoldered it. As you might notice, this board has no polarity protection. One might consider putting if you were doing a circuit like this, putting a diode or two in there to prevent polarity or reverse polarity damaging anything. So we're going to go ahead and power this up. We're going to take one of my little handy dandy variable power supplies, and I'm using that tweezer just to keep the leads separated. Using one of my, let me move this over, using one of my handy dandy power supplies. You can see a build of this. They cost like 20 bucks and they're real handy. I've got like 5 of them lying around. Anytime I don't want to drag out my full DC power supply, I can just use one of these for quick and dirty stuff. Of course, it slides all over the place because it's very light, but it's very handy. So that's at 12 volts. We don't want to be at 12 volts. Let's go down to 4.6, 4.8, that's 5 volts. So you press the button and it blinks for a while. It's counting up. The decade counter's counting, and it keeps counting and keeps flashing. I don't really know why it keeps counting, keeps flashing. Maybe if I stop it. Okay, that's a 4 or a 5. Oop, there it goes again. Okay, it's flashing, and I press switch 1 and I get a 2. Okay, and there's a 7, and there's a 5. Oop. Bunch of flashing, 2 again. Not real sure what the point of this is. I was kind of wondering that. There doesn't seem to be anything necessarily limiting or actually randomizing what you're getting, except when you press the switch, and maybe that's the intent. But I'm not getting a lot of variability here. And I'm also getting, obviously, on a normal set of die, you wouldn't have you wouldn't have an all-zero configuration. So it's an interesting, kind of interesting, maybe not very interesting kit, because the end result, again, the 555 is counting, is oscillating, and the decade counter is counting that and lighting up these pins as it reaches particular counts, which are going through these resistors to the transistors, which are turning on power to the LEDs. But I'm not real sure why this is a dice. But there it is. Again, I'm not sure I'd recommend this, but it's kind of fun, I guess. So, real quick build, but not a great result in terms of learning much or doing what it says. So that's what we have for this evening. Hope you enjoyed it.